All right, if you are just joining us, this is a webinar presented by AppGeo. I'm your host, Aaron Doucette, and today you are in for a treat as we are going to be taking an in-depth look at the MetroHD City Data Program from Hexagon, where we will be exploring ultra-high definition 2D as well as 3D digital twins of major cities. This is some pretty exciting stuff, fresh off the press, and we are here today with Trevis Gigliotti from Hexagon, who I'll be introducing in more detail shortly. But very excited to share this presentation with you all today and give you a inside look at this new program from Hexagon. So without further ado, I would like to introduce our guest speaker for today. He is Trevis Gigliotti from Hexagon. He is their Director of Technical Content Solutions, as well as their Content Product Manager. And we're really honored to have you back, Trevis. We've gotten the opportunity to interview you a couple times before, but this is our first presentation on this new MetroHD program. So just to welcome everyone, why don't you tell us a little bit about yourself, tell us a little bit about Hexagon, and then we can dive right into it.
Thanks, Aaron. Glad to see that I didn't wear out my welcome in the last interview. So happy to be here, and thanks. So like Aaron said, my name is Trevis. I've been with Hexagon for just a little bit over a year now. I have over 20 years of experience in the geospatial industry, mainly focused on photogrammetry applications, where I am a licensed or certified ASPRS photogrammetrist. Predominantly, my role at Hexagon is to make sure that we understand our business case and communicate that out to the customers and understand our customer needs and bring that back to our engineering production teams. So we're providing top level data to those who need or want to use it. And then my dual role is also making sure that we're keeping up to date and advancing the state of the art on the products that we are currently selling via our content program. So as many of you may already know, that is complete, coast to coast coverage of 30 centimeter data for most states. Some states are also 15 centimeter level. We have higher resolution metro areas that we sell via our store or streaming access as well. And then, the MetroHD content, which we're slowly starting to bring online, which we'll dive into a little bit more today.
Absolutely. And I think state of the art is the best word to describe the topic of today's presentation. I mean, many of you are familiar with the aerial imagery data sets from Hexagon. We've talked about them extensively in the past, but this is something a little different. And I think all of you on the call today are going to learn a thing or two new here. So let's look at this program from the top down. What is the MetroHD City Data Program all about, and where did this start from?
I can set the stage before we dive into the really good stuff. The MetroHD program is basically a high resolution aerial campaign that will leverage our CityMapper-2 sensor, which we'll get into more detail in the following slides, and then which provides a variety of subsequent data products that we'll be selling via our online store. The MetroHD will be its own initiative, and that will respond to customer needs and work for hire contracts, and then add that data back to as a licensed data back to the content program. And in addition, for those of you that may be part of the content program or Content Plus already, the MetroHD products, which we'll see today, will be part of that ecosystem as well. So instead of buying up metros at 15 centimeters for your state, you'll now be able to select the MetroHD products for purchase as we add those to our data store. MetroHD is meant to complement our traditional Hexagon content business that we just described, and also we'll continue to execute on the higher resolution metros that we require, but starting this year we'll add the components of today's presentation to the mix. So how did we get here to the digital twin model, which seems to be on the tip of everybody's tongue these days? Well, I can confidently say that the path is enabled by our unique set of core capabilities. Hexagon's legacy has always been linked to data. We're a leader in the sensor solutions that enable digital capture and positioning of the physical world. And in addition, our premier software solutions are used by industry professionals worldwide to unlock the value of that sensor data and offer the ability to design, simulate, and provide location intelligence of the real world scenarios that we're capturing. An interesting note is that in 2020, over 70% of our development employees have a software background, while only 30% are mechanical or electrical engineers. So we're starting to see that shift in our own employees that will allow us to further refine and combine our data with things like machine learning and artificial intelligence with our existing sensor and software pollution solutions to create a really powerful representation of reality. So as we forge ahead, we'll be putting all the pieces and parts together to drive the digital twin initiative from every level, leveraging insights from terrestrial and indoor to mobile applications at the street level, and to initiatives from the aerial perspective, like we're discussing today. We're continuously looking for ways to capture better data and transform that data into actual actionable information. All of this leads to what we refer to as the smart digital reality. And this is a digital, or creating a digital replica of the complete physical world, where all associated things, places, and processes within it are machine readable and subject to the power of algorithms. It's what we aim to deliver with every solution we provide. And so our core capabilities in sensor software and autonomous technologies give us a unique point of leverage, converging the physical and the digital worlds. And this is far more valuable than a continuous flow of information, feedback loop, or digital twin. Take any project that you're currently involved with that leverages geospatial data, perhaps a construction site or landscape. Imagine having seamless access to the physical world information about what's happened or happening in your aerial area of interest that's accessible to you from anywhere. This is really what drives it home for us.
Absolutely, Trevis. And I mean, for decades, we've been trying to take the physical world and take samples of data, images of our Earth from above, and take all of that and make a digital representation. We're getting to the point where that has become so seamless that just so many more projects can be done. So many more workflows are now possible. And we're going to get into that a little bit later in today's presentation. I thought it would be interesting if you could walk us through kind of what the broader marketplace trends are that led us to this point, because it is an interesting story of how we actually got here. It didn't just happen overnight, right?
Yeah, so the MetroHD program is responding to obviously emerging trends in the industry. And what we're seeing is increased demands in capturing larger areas of increasingly higher resolution imagery and LiDAR point densities with also higher refresh frequencies. All of this for lower price and hopefully reduced environmental impacts. So from a sensor development, acquisition, and data delivery perspective, the industry is being forced to seek increases in productivity and delivery via creative business models that benefit their customers. So, a hybrid acquisition model focused on the world's metro areas is our first response to those trends. So, what will attempt to enlighten our listeners today on during this presentation is that hybrid acquisition from a sensor perspective drives us towards increased efficiencies as we collect. Collecting a combination of imagery and LiDAR concurrently also benefits the downstream product flow, where we're able to automatically generate and optimize data products with more streamlined turnaround times.
Absolutely. And for the technical folks in the room, I think this next section is going to be your favorite and an area that Trevis has a lot of experience and can speak to. And that is just, how is this data being collected? I mean, we know there's the impetus and the demand, and we know that Hexagon and Leica are under one roof, effectively. Long history of different instruments and sensors. Where has that taken us? And just what is being, put to use here when we're capturing the data for this program, and kind of what does it all look like?
Yeah, so if you want to advance to the next slide, Aaron. So as I stated previously, we believe the key to responding to industry trends will be the deployment of a hybrid imaging initiative that combines both passive and imaging and active imaging sensors into one package. Like I said before, the key benefits are reduced acquisition times, multiple modalities collected over one flight. So we get an increased efficiency on the flight side. The workhorse in the MetroHD program is our CityMapper-2 sensor that is a follow-on to our CityMapper-1 sensor that was developed in 2016. So while this may seem like a new concept, it's certainly not a new technology for us here at Hexagon and Leica. It's important to note that the CityMapper-2 system is composed of subsystems that are world-class on their own. This isn't an imaging system with a LiDAR system along for the ride, or vice versa. These are two very strongly operating sensor systems out in the real world. So what we're showing on this slide are the components of the CityMapper-2 sensor. At the top, we have our 2 megahertz Hyperion LiDAR. Down below, we have our 150 megapixel passive imaging system. The Hyperion 2 Plus LiDAR is a highly efficient, full waveform 2 megahertz linear mode system that allows up to 15 returns per outbound laser pulse. Our gateless multiple pulse in-air technology allows us to handle almost 35 points in the air at any one time, which allows us to take advantage of the pulse rate, but more importantly for the city mapping environment, handle the complex terrain that we see with buildings in the like. The MFC 150 sensor is a high resolution imager with almost just a little bit over 14,000 pixels in the cross-track direction. It collects both RGB and near infrared. So this is a full 4-band data set that we're able to produce. The most important part of the MFC system is forward motion compensation, which allows us to collect good imagery even in the challenging lighting environments of the urban landscape. And we'll show an example of that later. So, overall, with these two systems combined in one package, we have a system that provides everything we need in terms of multiple modalities, matching temporal consistency, and that we're getting it at one time. This allows for a more stabilized scene that is dealt with in post-processing. So we're able to generate the products in a more automated fashion with less manual QC.
Absolutely. And we're going to get into some of those benefits in detail. It sounds like big picture here, we're taking the best of both worlds, packing them into one device and sending it off on a plane to take a flight. And as a result, you're collecting two of the most important digital data sets in one go.
That's absolutely right. So if we can animate the slide sort of slowly, as I mentioned, the things we see are our 2 megahertz LiDAR system in the center. We see our two nadir-looking cameras at a 45-degree axis from the LiDAR. And then if we click through one more time, we see the 4 oblique cameras that are oriented in the cardinal directions with respect to the line of flight. So on the left, we're seeing the benefits of our forward motion compensation technology. The imagery was collected in a very low level lighting condition, as can be seen by the long shadows. And this was collected at very high speed. So you can see the top image doesn't have the benefit of FMC. So you see some blurriness in the overall image, some darker shadows that are penetrating. And then in the lower image where FMC is applied, I see much more crisp, sharp imagery. So that forward motion compensation really allows us to be much more efficient in our collections, but collecting the best data that we can deliver.
Absolutely, and the detail that we're able to pull out there is pretty impressive when you consider the difference between the two. And let's go one step further here and explain what we're looking at in these diagrams.
Yeah, so what we see here, Aaron, is the benefits of the scan pattern of the Hyperion 2 Plus LiDAR. It's a conical scan pattern. So we get both forward and back as well as side-to-side views while we're collecting the data. And we can see the manifestation from that in the lower graphic, where we get more points onto the facades of building and greater overall sort of pattern densities in the data. If we go through one more iteration on the slide, We see that in the upper image, we've selected a cross section of a data set in Munich, Germany, and down below we show the corresponding point cloud. You can see that not only are we good at getting good top level representation of the trees and the structures, but we're also getting significant points on the facades of building, which become increasingly important when you're trying to model the urban environment where there's lots of buildings and structures.
Very exciting. And let's take a look at what that looks like when we put it all together. And this is what we're kind of calling this hybrid initiative, hybrid meaning LiDAR and imagery in one combined pass.
Yeah, so the final result of this, Aaron, is that when everything's combined, we get this, stout and robust image data in products, right? So here we see point clouds classified by elevation, encoded with spectral information, which are then combined with other derivative data sets. Because everything's co-Bohr cited, one GNS solution, one data collection instead of one for imagery, one for LiDAR, you see a really strong correspondence between the raw data and then the products that are generated from it.
Absolutely. Those are some pretty stunning visuals already, and we have many more examples to come as we go deeper into the conversation. So I wanted to continue this thread a little deeper here. We've understand now the technology behind collecting in a hybrid model, packing all this into one sensor, but from a methodology perspective, what are some of the benefits that actually come to light when we do both at the same time? Traditionally you may fly one and then come back and do the other and then match up the data sets in your software after the fact. But what do we get when we do both at the same time simultaneously from a processing perspective, and what does this actually mean for the customer?
Right. So in addition to, one of the strongest things in my opinion, which is collecting both of the data sets at the same time, co-Bohr sighted and aligned, we're able to take advantage of the best aspects of both passive and active imaging. This means high accuracy in the two dimensions, so in the horizontal frame from the imagery, and then adding to that the more accurate vertical data points as well from the LiDAR. So in terms of point cloud derivatives, a combination of strong top surface models from the imagery with the multiple returns of the LiDAR provide a comprehensive representation of the physical world. You have the good surface, you have some penetration with the LiDAR, so you're able to sort of fully represent the entire scene that you're looking for. And then finally, and what we'll get to in some of the slides after this is, the integration of LiDAR augments the imagery model reconstruction in low light conditions such as shadow or in darker environments, which can be challenging to traditional photogrammetry in the urban environment. So you're able to sort of optimize your collection times using both approaches.
Absolutely. I mean, when you think of a camera taking a picture, you need light, right? But LiDAR, in theory, can work in a pitch black. So it can kind of fill in the gaps a little bit, give us more detail in those areas, especially in the urban environment. Lots of tall buildings, lots of trees, helps us fill in the missing pieces of the puzzle, so to speak. So let's look at that in this scene here. What are some things that we want to be looking out for in our image that this hybrid approach is going to actually help us out with?
Right. So this slide, we want to illustrate the areas where traditional photogrammetry struggles and LiDAR takes over in our process by adding a bit more robustness to the data, right? We're really focused in MetroHD on getting the geometry right. And that's what the augmentation of the LiDAR sensor really allows us to do, right? So point clouds generated from imaging only, even if flown with very dense overlaps to facilitate dense matching, still have problem areas. And so we're looking at some of those right here, occlusions and canyons. Very difficult to get the 2 points on the surface or on the facades of buildings through traditional photogrammetry, where you're looking for, the acquisition and matching of the stereo pair to generate that elevation information. In these tight areas that are often shadowed and geometry restricted, LiDAR can take over there. LiDAR also helps us on non-textured or highly repetitive textured surfaces. This is where sometimes you see traditional photogrammetry break down and produce a lot of noise, or no data points at all, where a definitive match in another image can't be found to generate that stereo look to generate the elevation. And then, moving on further, LiDAR does give us the ability to have some vegetation penetration, so we can see below trees and such in the environment. And then finally, again, we're looking at shadow areas. So in areas where we traditionally see low elevation points and data integrity in a traditional photogrammetric approach, LiDAR is able to pick up the slack there.
Absolutely. And of course, when all of this starts out in the sensor, it's collecting a series of points, right? And it's up to the software to put all those together to a cohesive 3D model. And that can be really tricky, right? So when we look at the left and the right here, it looks like on the left we have image only, what that might look like. And then on the right, combined with the LiDAR, some of the benefits that come from having both models available to us in the processing stage, right?
Yeah, that's exactly right, Aaron. So this is a terrific example of what LiDAR can bring to urban mapping. So on, like you said, on the left, we see image only. On the right, we see imagery and LiDAR, and we see improvements in the model. So the first area that you've highlighted there is a vertical surface. In the image only approach, we see some noise. We see some discontinuities in the data model, which leads to an incorrect or a less than optimized reconstruction of that area. And then on the right, by adding LiDAR, and remember that conical scan pattern, where we're putting points onto the facades of building, we're able to see improvement in that modeled surface. And then continuing on, like I had mentioned in previous slides, looking at tight areas, which are included by geometry, but then also suffer issues from shadow as well. We see some definite lower level reconstruction in the image only approach, and then that is cleaned up when we add LiDAR to it. And then finally, looking in just shadowed areas that are in the backyards of buildings, we see improvement also in the resultant modeled approach when we do add LiDAR to the mix. You're seeing not only better representation of the structure itself, but more optimized surfacing as well.
Absolutely. I think another great example that I've seen in just browsing through data like this is when you have a bridge, right? So many times you will get to a bridge and underneath is like it's gone into alternate dystopian reality, right? But yeah. It sounds like this is another way to help clean up those situations and areas with overpasses and roadways that, logically we look at it from a picture and know what's going on, but a sensor or computer can have a really hard time telling what that is.
Yeah, that's exactly right. And so here's a further example of that, right? So we have the image only approach on the left, again, and the imagery and plus LiDAR on the right. So a couple of things to note here. You see better modeling in the shadow areas. You see a better transition from the surface to the building in the imagery and LiDAR approach. And you see more consistency modeling of the scene. And again, this gets back to our concept of concurrent data collection, right? We're able to model that car in the appropriate place because we're collecting LiDAR and imagery at the same time. If we were doing this in two separate flights, you would have the car in one and not the other, or vice versa. So that in itself creates an issue in your final model, or requires additional QC and potentially manual editing down the road.
Absolutely. So many times you see an anomaly in the LiDAR data, and you go and look at an aerial image and there's nothing there, and try to piece it back together, only to realize, between these two collections, that building was torn down, or it was a hole in the ground that they have now filled in. This takes some of that mystery and the guesswork out, which can really be expensive in terms of man hours to QA, QC those anomalies.
Yeah, for anybody that produces LiDAR data, pouring over that data to remove all those inconsistencies can be quite expensive, like you said. And then finally here, we see a little bit of improved geometry reconstruction when we're adding LiDAR in the forest environment, right? So on the left, you see a bit of blurriness and no definition under the vegetation. On the right-hand side, you're able to make out a little bit more definition under the tree canopy, but you're also able to make out one of the trunks of the tree there, which is an enormous benefit over the image-only approach.
Very cool. So to recap this section a little bit, we looked at the benefits of a hybrid collection model and why it makes a lot of sense actually to collect your LiDAR and your imagery concurrently. In the next part of the presentation here, I'd like to talk about, now that we've collected all that data, what are the resulting layers that are actually our end product here when it comes to the MetroHD city data. And if we can go into those, and these are the things that I think a lot of our audience probably have experience working with individually. Now they're going to get them all in potentially one bundle.
Yeah, that's right, Aaron. If you move on to the next slide. So 10 different data sets come out of the MetroHD acquisition process. So there's a couple that are familiar probably to the GIS and aerial imagery users out there. Standard Ortho, True Ortho, DSM, DEM, and then just the nadir or oblique imagery is as well, right? And the point cloud data. You know, that's really what we're focused on as sort of our core deliverables of the MetroHD program. But we extend that through more advanced workflows to provide tree models, LOD2 level building models as well. And then finally, a culmination of all of that, which is our fully rendered and texturized 3D mesh model of the AOI.
Absolutely. And it's pretty impressive that all 10 of these are coming out of one flight and an out of the box product effectively. I know there's many cities who have spent years, producing these on their own as a, combination of one or more flights. So this could be a real time saver there. So let's look in a little more detail at each of these layers just to give people a sense of exactly what they're getting.
Yeah, so the first data set that we're looking at here, Aaron, is our True Ortho product. So in addition to our standard ortho rectified imagery, which comes out of the data collection, we offer True Ortho rectified product as well, which is rectified using the LiDAR DSM as opposed to a DEM. And so we're able to remove the appearance of building lean in the imagery for those that aren't familiar. And so each pixel is represented as viewed directly from above in its true orthographic position. So the important thing to note here is this is a bona fide 2D map with high resolution imagery as its context. The normal GSD for the imagery that we collect is 5 centimeters, so it's extremely high resolution. So once you've improved and removed building lean, that means you're removing all the inclusions from seeing sidewalks and streets. So you're able to better extract building footprints or seeing the street furniture and infrastructure that's on the ground. So it really makes an ideal tool for urban planning or even extended feature extraction. So like I said before, this is delivered as a 2-inch or 5 centimeter product for spectral bands in GeoTIFF format. And it's also tiled for delivery.
Yeah, 5 centimeter imagery alone is pretty exciting, but let's see what else we've got coming up out of the box here.
Yeah, so what we see here is the LiDAR point cloud that comes out of the MetroHD process. Again, because we're collecting it concurrently with imagery, we're able to spectrally encode those points with either RGB information or CIR information, which makes data interpretation a little bit easier to the untrained or even the trained eye when you're taking a look at this data set. So in addition to the spectral encoding, we offer this with standard LiDAR intensities. This data product can be further classified as per ASPRS standards or classes. Out of it can be derived further products, such as our DSM, which we'll show in a second, and also DEM as well. This is also high density LiDAR data. we're trying to collect 20 points per square meter on the acquisition side. We don't always achieve that, but that's certainly our target. So, we're in the 15 to 20 points per square meter range, which is extremely high density LiDAR.
Great. So let's keep looking. And now it appears as we have, I think this is back to imagery, but let's go one further.
Yep. Right.
So now we have,
I think we might have gone one too far. Yeah. Can we back up one, Aaron?
Sure thing.
We jumped from point cloud past, right? So this right here looks like imagery, but that's actually a very good complement. This is our aerial mesh data, right? So this product is derived from a combination of both imagery and LiDAR to create that virtual representation of the real world. So for those of you that aren't inherently familiar, the aerial mesh is a product where a mesh of triangles represents the surface of all natural and built up objects within the image scene. Aerial mesh texture, so the visual component is achieved by assigning the oblique data from the CityMapper-2 sensor to each corresponding triangle, right? So it's kind of a tin on steroids for those of you that are familiar with that data structure model. So this is a great product to observe and monitor change, used for landscape planning and analysis, city planning, smart city integration, line of sight, and other further transportation analysis. This is the digital twin, if you want to call it that.
Beautiful. So now we can move on to tell us what we're looking at here.
So this is our DSM product. So again, this is generated in an automated fashion from the LiDAR data. This is generated from first return LiDAR points. So this is representing all primary reflective surfaces in the built up environment, such as buildings, transportation, and other general infrastructure, including also natural features such as trees and shrubs and the like, right? So we see this as a very popular product moving forward for use in line of sight studies, being it for solar or RF planning, as well as volume estimation and asset inspections.
Excellent. And moving on one step further, this to me looks like the land classification.
That's exactly right. So we use an artificial intelligence approach to generate a land use map that can range from anywhere from 20 to 25 different classes, where each pixel is assigned to one of the classes, such as pervious surfaces such as grass and trees, or impervious ground cover such as concrete and asphalt. We also identify vehicles, rail tracks, and buildings, just to name a few. This is a product that closely corresponds with the nominal input resolution of the imagery. So again, this is a 5 centimeter or 2 inch product that we're delivering as a GeoTIFF file format.
And it looks like, yeah, you have different vegetation classes automatically pulled out, impervious surfaces versus building footprints, and even those train tracks, all as unique assets in this resulting product.
That's correct.
Okay, one step further.
Yeah, and I think this is the final data set that we'll dive into. This is really a combination of a couple of data sets. So we see the land cover, land use classification as the base map here, but we also see integrated on that as our LOD2 building models. So for those of you that are unfamiliar with the LOD2 level process, LOD0 is just a two-dimensional footprint. LOD1 is the extension of that footprint into what they call a sugar cube. So there's no roof definition. But in our level 2 product, we have roof definition, where we're we're getting orientation and pitch in various aspects on the roof structure. So you can see that in the orangish or brown color buildings that we've identified here. And then finally, our 3-dimensional tree layer is also integrated here, where we're using the imagery and the LiDAR to actually do a modified sphere tree crown model. So it is, sort of loosely based upon the data in reality, although trees are very difficult to monitor to model with moving branches and leaves and all of that stuff. It's a really great, robust product.
Absolutely. Well, the trees are in bloom here in Boston, so a lot of change going on day to day, let alone week to week. Um, so I want to take the presentation a step further now, and we've seen some of the amazing data sets that come out of this process. We can recap them again at the end, just because it's a lot to remember, honestly. But these are all going to help people with improved decision making, and I hope that a lot of our attendees, that's exactly the kind of role that they're in, is helping with analysis and decision making at different levels of government or even private industry. So, let's think now from the perspective of one of the cities who are maybe interested in gaining some of this data for themselves. What are some of the use cases that LiDAR and especially hybrid collected imagery and LiDAR are going to open up for them that maybe they can't do today given their existing data or what they have available now? So this will be a little bit of a show and tell and a back and forth here, but I wanted to kind of walk through some of the exciting real world challenges that we can solve with these 10 data sets now at our disposal.
Yeah, that's correct, Aaron. So at a high level, we see sort of these four main market drivers for the Metro HD data. Just on its own, visualization and having a comprehensive model of your city or urban environment is huge and pay huge dividends. And we'll get into some of these examples later. Because we've accurately captured and modeled the city scene, we're able to input that data into a variety of simulation softwares. We can do informed decision making, further derivative, whether it's line of sight analysis with sound or light waves. And then, the final benefit of this data can be reduced site visits, right? If you're able to accurately capture the data that you need from the comforts and confines of your office, that's cost savings to your department or your organization or your program. We all know that costs rise exponentially as you put people out into the field. So being able to leverage these data sets from the comfort of your office and integrate with, perhaps your own project specific and integrate your own project specific products, further enhances the utility of the data.
Exactly. And it's not necessarily just about looking at the stuff, but once we have it in 3D space, we can measure, we can calculate areas of sloped roof. There are a lot of things that may have traditionally required someone out there with a tape measure and a ladder that now we can do from the digital side of things in the back office. So let's go into some of these now and just get a sense for what is possible. And feel free to narrate as we're flying over this scene.
Yeah, so this is just an example of our aerial mesh product, right? So you can see not only the comprehensive nature at which we're collecting, but also the high resolution and detail that you're able to see in the city scene.
And here we have another example starting at street level and going up.
Yeah, so the beautiful thing about here, like I mentioned before, Aaron, since we're getting the geometry right, we're able to integrate with further sensors and data sets, right? So we started off there showing actually a mobile LiDAR collect, right? And we're able to integrate that with our aerial products as well. So we're able to get, accurate representation of the ground scene and then extend that up to fill in the gaps or the holes by the aerial data products as well. But we couldn't do that if we didn't have the geometry right, which again goes back to the benefits of the LiDAR data that we're collecting. And I'll have to point out that this type of data where we're integrating the street level data, it's still in R&D phases. It's not an absolute bona fide product of the Metro HD program yet, but it just gives you some insight as to where we're headed. Street level combined with aerial, and then who knows, maybe we were able to walk into one of those buildings one day and get a fully fleshed out model of the inside of those structures.
Absolutely, really entering a whole new phase of augmented and digital reality. I wanted to take it back to some of the work that we do here at AppGeo and some of the projects that we've worked in that touch on all of these data sets. And hopefully these are relevant for our audience as well. This is huge for flood inundation modeling, where we need an accurate representation of the elevation of a landscape or along a river to understand if that water level rises, well, where is it going to go? Of course, that is all based on the DEM and DSM products, but having those building outlines are going to be helpful too. You may be able to easily calculate, which buildings may be impacted by flooding. And these are the sorts of projects that we've worked with in the past here at AppGeo. I think here's another example of that same sort of thing with the MetroHD data. We have a river at different stages of water height. We can see where that water is now coming into the town and very cleanly wrapping around the buildings, going through the streets, matching up with the base elevation. This is really important stuff for a lot of cities and metro areas who are tasked with protecting lives and property, but also planning for the future and running different simulations. The better your input data, the more accurate those are going to be. We've seen that with our clients as well, looking at evacuation mapping, emergency management. More and more of these types of users are relying on 3D data sets in addition to their 2D, which they've had for decades now. Another area that we have been really passionate about recently is tree canopy mapping. Of course, you talk about trees models as one of the outputs of this MetroHD platform. So that's really exciting for cities who are trying to get ahead of their tree canopy inventory. But, the input LiDAR is really necessary to get a concrete tree inventory count and canopy extent. These are some examples from a project AppGeo is undertaken in Cincinnati, Ohio. We had a great webinar on this in the past, which is where these images are from. But being able to look at these changes over time, you're going to need good LiDAR to do it. So again, keeping the need for these data sets in the front of our minds as we want to get into these more advanced projects that we have trailblazers like Cincinnati and other cities across the country taking part in. Really important stuff for urban heat island mapping, for urban forestry. The list goes on. And I wanted to pass the mic back to Trevis to talk about a couple of the more advanced simulations we can do here in the 3D space. Tell us what we're looking at here.
Yeah, so again, this is a wind simulation using our 3D mesh environment. So not only are we looking at reality here, we've expanded beyond just the drawing the generic shapes and hoping to get the location and positional accuracy right. So we're modeling using real world representations of the scene, which is tremendously helpful, be it for wind simulation or we're even looking at autonomous driving applications as well that leverage this type of data.
Absolutely. And here's one more example in the 3D space.
Yeah, this is a line of sight analysis, right? Which we're seeing a lot of popularity in the RF planning space, seeing how signals are propagated, where blockages are. We've also extended this to some of our internal departments looking for GPS signal blockage. The good thing about leveraging the real world data that we're able to provide is you get beyond just the physical location and the size, but you get some idea of the material construction as well. So when you're talking about, for example, RF planning, they're interested to know, okay, I know that it's blocked, or I know this is in the way. Is it glass? Is it wood? Is it steel? And how will that affect things going forward? So having that further level of detail really helps.
Absolutely. And for any of these simulations, when we're thinking from a planning perspective, we might have the model of a proposed building that hasn't been built yet, but being able to plop that into the real 3D space of what exists now, we'll be able to tell things like how will the shadows of this building affect the park next door or the view of the skyscraper nearby, right? There are all these problems that we can account for when we're working in that 3D space that are a lot harder to calculate in 2 dimensions alone.
Yeah, that's exactly right. Like, some urban centers are looking at heat mapping, right? So that provides a great indication of wind and airflow, plus solar blockages. So it all factors in. But having that level of detail in the real representation is what makes it great.
So just a couple more visuals to wow everybody a little bit. This one I
Yeah,
found
this one's
with the
just
color
pure eye.
alone.
This one's just pure eye candy, Aaron. This is just showing, the density of the LiDAR and also the high resolution of the imagery data, right? You're able to see the detail in the stadium mapping. You're able to see full representation of trees, lines on the pavement in street areas, lines on the track. Just a stunning representation of our data.
Absolutely. So just imagining what we could do with this at our fingertips. And I think we have one more just to show all those different layers coming together.
Yeah, this just brings it all together, right? The formats that we've decided upon for this data are flexible and generic as they can be, right? So you can use the 2D products in connection with the 3D products. The formats are able to be integrated in most common GIS software packages, as well as more advanced or custom modeling applications. But the diversity of the data set is kind of what brings it all together to make this a really powerful representation and a comprehensive one at that of what's going on in the AOI.
Absolutely. And so much value too comes from the change detection. Like we want to understand how things are changing from one time period to the next. So after that next revisit, will cities be able to take these layers and say, understand how their impervious surfaces are changing over time, or how their canopy is changing over time? I know that's so important to a lot of users.
Yeah, Aaron, the old project management adage works. If you can't manage it, if you can't measure it, right? And so we give the capability to measure it.
Excellent. All right, so we have just a few minutes left, so I want to bring the conversation to back to the practical side and understand what is this program going to look like for an end user or for a customer, and what can you tell us about the procurement and the availability and just how they're going to get at all this stuff, because there's a lot to bite off here, right?
Yeah, they're big data sets. I'm not going to lie, right? We've moved to what they call big data, right? So the data is currently available via traditional shipment, or can be transferred directly via Amazon S3 buckets. We'll find a way to get you the data currently, but what we're showing here is where we're moving to in the future, and that's our HXDR platform, right? So HXDR is short for Hexagon digital reality platform. And so the HXDR platform is an attempt to visualize and collaborate on all of this data in one platform. So if you go to the next slide, Aaron, we can really show the vision of this. So the HXDR platform will allow us to get all of these data sets, whether they be base data sets, advanced 3D data, and even data sets that are generated from mobile or terrestrial data sets, into one common platform to be able to model and analyze the environment. So this is the future of how we will share this data. This is the future of how our users will be able to purchase the data. They'll be able to log on to the platform, select an AOI, select their data layers of interest, and then download those directly to their platform for use in other softwares. We're not quite there yet, but this is the vision.
Wow. I think we're going to have to circle back to this for a whole another webinar topic with you, Trevis, because this sounds like a very powerful and all-encompassing platform. But yeah, exciting things to look forward to. And just to recap here, these are all of the data sets, all of the 10 that will be included in this program. So if you have any further questions on any of these, we'd be happy to go into more detail, but I think it's important to take stock of all the different layers that you would have available. So I wanted to finish things off by just asking kind of what's next. Where are we in the sequence of the launch of this new product, and what should people be staying on the lookout for over the next several months?
Yeah, that's a good point, Aaron. So, we're slowly rolling out the MetroHD program here in North America. We have a couple of test data sets that we've put together to allow people to see and visualize those. And in the next couple of weeks, we'll have those data sets put together in more of a sort of a digital sandbox environment where you can log on and take a look at the data for yourself. We've been doing a lot of this work in Europe, so the workflow and delivery and productization of all this stuff is sort of really maturing over there, and so we'll bring that to North America this summer as we set out to collect some cities here in North America to start populating the content program.
It sounds like it's going to be an exciting summer for sure.
At least for our pilots.
Yeah, they'll be busy. Well, I want to thank you for being such a great guest today. And as Trevis mentioned, there's going to be demo data available for, I think, all of the data sets that we covered. So if you want to get your hands on this stuff and try it out in your own software to imagine what it will be like for your area, you can do that, sounds like very soon. So be in touch and we can connect you to those resources. And from here, I wanted to make sure we open things up for questions and taking advantage of the fact that we have Trevis here to help answer those. While I'm waiting for those questions to come in, I'll give everyone a quick promo for where you can find more content. We've had several webinars with Hexagon. You can find them all on our webinar repository on the mapping channel, as well as appgeo.com. And on this channel, we cover a wide range of topics, all things geospatial, and interview some of the most prominent figures in the industry. So again, we are open for Q&A. I know we have Trevis for about 5 or 6 more minutes before he turns into a pumpkin here. But yeah, feel free to ask away. And if there's anything, again, that we didn't cover that you want to see, feel free to reach out via email and we can get in a deeper conversation that way. We do have a couple questions here, Trevis. So one is asking, will this data be offered in compatible formats for open analysis? I assume they're like being able to work with common software like QGIS and all those open source type of data standards. Anything you can say for that person?
Yeah, we provide our data in generic formats, so it can be pulled into a wide range of software packages. The LOD2 and tree models and stuff, we offer those in OBJ as well as vector formats. So we can pull those, so they can be pulled into Esri or QGIS and those types of packages. The more advanced mesh, again, we provide a couple of flavors of that. We have OGC 3D tiles, which a lot of the more advanced modeling packages are able to handle, SLPK formats, which can be pulled into Esri, and then the more generic OBJ file format, which can be pulled into the remaining things. All the more traditional geospatial data sets are in data formats that you would expect, GeoTIFF, LAS for the point clouds and stuff like that. So yeah, we're trying to make this data as available and wide ranging as possible.
Great. Couple more questions here. This one is more of a comment from Greg. He says, good to see you, Trevis, and he'll be in touch as they're considering 3D data for their county.
Greg is an old colleague from my university days. I saw that come through. Good to hear from you, Greg.
Yeah, thanks
and
for
hope we can catch up. Yeah.
One last question that I see so far, but again, you have a couple more minutes with the expert here. Is this a licensed product? And I think that's a very good question, actually, because we've talked a lot about licensed data in our past webinars and past topics. How does the licensed aspect apply to this MetroHD initiative?
Yeah, that's a very important question. Yeah, so it's the same as our content program, licensed subscription based model for data usage, right? So um, cost savings get passed on to the customers. We're able to use and sell this data multiple times after it's collected. Once it's collected, it all becomes part of the Hexagon content program ecosystem that people can use at their discretion. So yeah, licensed and subscription model for sure.
Very cool. So just to wrap up here, it sounds like we're building, this worldwide almost ecosystem of imagery, of LiDAR, of models. They're all going to be available to tap into. And it sounds like there are very exciting times coming for the cities that will be included in the program ahead. I think we will wrap up here. Again, you can find us on appgeo.com as well as on the mapping channel where you can find a copy of this recording. I want to thank all of you who stuck it out here to the end and anyone who might be watching on demand. Trevis, any closing thoughts before we close out today's session?
No, I think we sort of covered it all there, and that was a lot of stuff.
Yeah, absolutely. Well, there's a lot involved in the program, and I'm glad we had you to help um, open it up a little bit and get a deeper and more clear understanding of it. So thanks again for coming back on, and we'll look forward to having you back next time.
Anytime, Aaron. Thank you.
Great. And thank you to our audience as well. Have a good rest of your day.